When we look at this, keep in mind that for elimination, it's not always going to be very straightforward for you. Sometimes you do need to multiply one or both equations by a number. That number could be positive or negative to eliminate a variable. I want to just keep in mind, I'm going to draw a little star here. It needs to, your goal is to have a positive and a negative of the same number letter combination. Okay, so if you don't have that, then you're thinking about, okay, what do I need to multiply or what do I need to do in order to get a positive and a negative of that same number letter combination? And we'll elaborate on that today. Our first problem here is very straightforward. We did talk about looking at things vertically. So you can see here, do we have a positive negative of the same letter combination? Yeah, we do, right here on our x's. And if we have a positive x and we take away an x, then it ends up eliminating or canceling. So then we can just go through and put the rest of the things together. We can put a 1 in front of this y if we want. How many y's do we have? 3 y's. And how many regular numbers? 18. And now it's a 6th grade problem. So in order to solve this, we're going to what? We're going to divide. So y is 6. Now remember, your solution is going to be an xy coordinate. So there's our y value. Make sure when you write your coordinates, you put them in the correct order. I've seen a couple people flip-flopping the x and the y. So now we need to get the x value. So we talked yesterday about going through and picking an original equation. It doesn't matter if you choose the first one or the second one, you're still going to get that same answer. Do we have a preference, first or second? Second, all right. So when we plug this in, we have negative x plus y, but what is my value for y? We've already solved that, yes? So we're going to put a 6 there, and then we have 5. And now this is a 6th grade problem again. So undo the add subtract. We're going to minus our 6. Now be careful because this is a negative 1x equals negative 1. Be very careful with those signs. When we divide, we do not change the sign of our number. So we are dividing by a negative 1. Negative divided by negative is a positive. So when we look at this one again, nice and pretty for us, we can eliminate what? The y's, right? Because we have a positive, negative, same number, letter combination. So now I'm going to put my x's together. Be very careful with your signs. A negative 3 and a negative 4 is a negative 7. And a negative 7 and a positive 14 is a positive 7. So now we're going to solve it. We're going to have to divide by a negative 7, right? Because a negative divided by a negative, that gives us that positive 1x we want. That's why we don't change the sign when we divide. 7 divided by negative 7 is a negative 1. Are we finished? Nope. You got to pick one. You want the first, you want the second. Doesn't actually matter. They're both ugly. The second I heard someone say. So we're going to say negative 4. But in place of x, I'm going to put negative 1 plus 5y equals 14. This is just like what we did with substitution, right? Negative times a negative is a positive. Undo the add subtract. Undo the multiply divide. So my solution coordinate is negative 1, positive 2. So that means if we were to plug those values into our original equation and we put it in our yellow calculator, we should in fact get true on both of these equations if you wanted to check it. On this one, when we look vertically, we do have the same number letter combination with the two x's, but the problem is they're both positive. And in order for them to eliminate, we need one of them to be a negative. So we talked yesterday, we don't want to change the numbers so we can multiply by 1, but we do want to change the sign. So we need to multiply one of these by a -1. And it doesn't matter which one you do, right? Just like when you plug in to get your second value, you can pick, do we have a preference? 1 or 2? 1, all right. So I'm going to multiply this top one by a -1. Now, when we do that, we have to make sure, 1, that we rewrite it. And 2, we have to make sure we distribute all the way through our equation. So a negative times a positive 2x is a -2x. And a -1 times a -y. A negative times a negative is a positive. You could put a 1 in front of this if you wanted. And a -1 times 7 is a positive 7. And then I'm going to rewrite this second one right below it. And now I can see that my x's now cancel. So now we can move on. So sometimes we have a little bit of an extra step there. 1y and 7y is 8y. And 7, oh, look at what I forgot to do. A -1 times a positive 7. What should this 7 be? It should be negative, okay? So I messed up on my signs there. It happens a lot, but that's why we say all the time, be very, very careful. So -7 and positive 31 is 24. Now we divide. Y equals 3. So now I need to plug it in. Do you want to use the first or the second? And we need to use the original ones, not the one that we changed. All right, so I heard someone say second, so we can say 2x plus 7. What am I putting in place of y? 3, thank you. And I know that 7 times 3 is 21. And now it's a 7th grade problem, right? Undo the add, subtract. Undo the multiply, divide. X equals 5. So my solution on this one would be 5, 3. So when we look at this one, notice nothing is going to cancel. We don't even have a matching number letter combination. What we do have is we have a positive and a negative and a negative and a positive. So on the last one, we multiplied by a -1, so the signs would be the opposite. Our signs are already the opposite here. So we don't need to multiply by a -1, but we might need to multiply by a regular number, okay? And it's going to depend on if you want to get rid of the x's or you want to get rid of the y's. If we wanted to get rid of the x's, what would I need my x on the bottom to be to eliminate with that 3x? -3x. If I wanted to get rid of the y's, what would I need my y on the bottom to be to eliminate -2y? +2y. So you need to just decide, are we going to get rid of the x's? Or are we going to get rid of the y's? So what are we thinking? The x's, I heard, okay. So in order to get rid of the x's, we said we need to multiply this by what? By 3. So it is super important that we rewrite this so that we're not trying to cram all of our changes in there and then we can't read what we wrote. So there's my first equation. On my second one, we need to distribute all the way through, and we'll see if I can do that correct this time. So -x times 3 is -3x. 3 times y is just 3y. And 3 times 1 is 3. So now we can see, in fact, that my x's will cancel. On my y's, I have a -2 and a +3, so I get a +1. And on my regular numbers, 3 plus 3 is 6. So my y coordinate is going to be 6. And now we need to, again, pick one to plug into. Do you want to use the first or the second? Sure, we'll use the first. And again, just the original. So 3x minus 2. What am I putting in place of y? 6 equals 3. Distribute. 3x minus 12 equals 3. We can add the 12. And then we can undo our multiply by dividing. How many 3's are in 15? 5. So because on this one, nothing is nice and pretty, we don't even have that positive and negative, we can't make 6 become 9 and we can't make 2 become 13. We're going to have to multiply both of them. So you really need to decide if you're going to eliminate your x's or your y's. Probably the x's are easier. In elementary school, you learned how to list out your multiples like this when you were learning how to find a common denominator. Do you remember doing this? And then you'll be like, oh, 18. So really, that's kind of what we're doing here. If we're going to make them both 18, then we're going to have to say this top one needs to be multiplied by 2, and this bottom one by 3. Now, the only problem with that is they're still both positive. So we're going to have to make either the 2 or the 3 a negative so that the signs are different. So if we make the 3 negative, then when we multiply by that -9, it'll become a positive. That's kind of nice. But you could also make the 2 negative. It's up to you. Either way, when you write this, you need to rewrite it, and you need to make sure you distribute all the way through. So 2 times 9 is our 18 that we talked about, plus 4y. 39 times 2 is 78. And then down here, you're going to multiply by this -3. And again, be very careful with those signs. So a -3 times a positive 6 is a -18. -3 times 13 is a -39. And a -3 times a -9 is a positive 27. So once you've done that, now it's just like what we did before. We can eliminate our x's. Be careful with your signs. 4 and -39 is -35. 78 and 27 is 105. Then we would need to divide by our -35. Y equals, I believe that's 3. -3. Don't forget the negative. And then we can take and plug that into, do you want to use the first or the second? What do you think? The first? So we have 9x plus 2 times -3, because our y was -3, equals 39. Positive times a negative is a negative. We're going to add 9x equals 45. So x equals 5.